Hello, welcome back to my ICE tutorial series. This is episode 5, and today we're going to be starting to talk about variables in ICE. So last episode I talked about loops, and it ran really long because I talked about all the loops in one video. So I'm going to split up the variable videos, and we're going to talk about the variables one at a time. Today's going to be talking about integers, which we've already covered a little bit, but we'll go more in depth right now. In the future, we'll talk about strings and lists, but for now, I'm going to start with integers. So what is an integer? Well, an integer is a number without a decimal point. In ICE, you can't use fractional numbers, right? So if I try to use 1.5 in an ICE program and I write out 1.5, ICE will error. It won't let me run it. So if I try to compile that program, it says this token or function is not implemented yet. And that's because you can't have a decimal in ICE. You have to have a whole number. So what if I have an operation that would give me a decimal? Say I have 9 over 8. Well, 9 over 8 is going to give me 1.125. But instead of storing 1.125 in A, ICE is just going to store 1 into A, because ICE gets rid of the decimal part of the number. So it doesn't matter if the number is larger, right? It's not about rounding. So it's always going to go to the lower value. It doesn't round up. It always rounds down, is what I'm trying to say. So if I have 1.9, it's still going to store 1 in A. If I have 3.9, then it would be 3, is what in essence this would do. So if you have, division that would give you a fractional answer, ICE is going to remove that fractional part. So you can't have decimals or fractions in ICE. Now, negative numbers. You can use the negative sign, and numbers can become negative in ICE. But what ICE does is it takes any negative number, it takes 2 to the 24th, nope, that's 2 to the 200th, 2 to the 24th, and it subtracts the positive value of that number. So if I had a number like -5, and I put that in my ICE program, ICE doesn't interpret that as -5. Instead, it interprets it as this number minus 5. So obviously, there's a big difference between this and -5, which is why you probably won't be using negative numbers very much in ICE. It just doesn't really help you out much, at least not right now with what we're doing. So as a general rule of thumb, stay positive numbers, and use whole numbers. So those are the values that we can store in our integers. What about integer naming? So we know to store a value into integers, we use the store value. We talked about that in a bunch of other videos. So we use our store value, and then we put the name of our integer. Now we can name our integer variable anything we want. It can be anything from A to theta, capital letters in TI Basic, and it can be up to 10 characters long. So I could store a value in A, or I could store a value in B, C, D if I wanted to. And now anytime I use these later in the program, they're going to have that value. So now I could do math with these. I could do BCD times A, and I can store that in another variable if I want to. So you can take these integers and you can do math. If you're doing operations, it follows PEMDAS, so obviously parentheses first, so you can use parentheses in ICE. And it just follows the rules, multiplication before addition or subtraction, and those things. There is no implied multiplication, which is important. So if I had a times, in any math class, we would interpret this as a times 5. ICE doesn't see it that way. If we want to do a times 5, we have to do a, and we have to actually put in the multiplication symbol. Okay? So that's operations. Everyone knows how math operations work, hopefully. So that's that. Another note about storing: if you have the same value that you're storing in two variables, you can actually chain the storing together. So I can say 54 stored in A, stored in B, C, D. So before these were on two separate lines, I can combine them into one line, and this is more efficient if it's like this. So if you're storing the same value into two variables, you want to chain them together like this. Okay, so that's the basics of integers. Now let's talk about getting random numbers, because when you're making a game or another program, a lot of the time you want a random value. So you want your player's character to get random loot or fight random enemies. So how do you get a random value? Well, you can use the rand command, which is going to take a random number from 0 all the way up until 2 to the 24th, which was this big number. And it's just going to take a random value from 0 to that number, and it's going to output it. So when it outputs it, we can save that output by storing it into a variable. But we can also call it without saving it. So I could say if, and then I can actually use that random as part of the argument for the if statement. So maybe I want my random number to be greater than 5. So I can use that as part of my argument. But if I use it like this, it's going to call this random number generator, and it's going to compare the random number to 5. And that's all well and great. But if we want to then do math with our random number, so we're in our if statement, and now we want to take that same random number and add 5 to it. Well, we can't do that because we didn't save our random value. Because if we just use rand again, it's going to give us a completely new value. So if we want to save this, say we want to do this random value plus 5, we're going to have to store our random value in a variable, compare the variable, and then add 5 to that variable. But what if, say, I don't want a random value from 0 all the way up until 2 to the 24th? What if I want to have a range? So there's another command for that, and that command is random integer. It's randInt. And here it is. The arguments for random integer are your starting number and your stopping number of the range, your low and high number. So if I want a random integer between 10 and 20, I just do 10 comma 20, and then I can use this as an argument, say in an if statement or a loop like we saw, and I can also store the value. So I could store it in A, and then we can just display A if we want to, and then we can pause. So let's just see that in action. Okay, so A is 16. If we run it again, A is 20. It's going to be anywhere between 10 and 20. Oh, it's not showing the number because we didn't have a clear home in there. Something that I never mentioned about the display command, I don't think, is that there's a cursor position on the home screen and that it can run off the home screen, which is something that we're actually going to talk about right now, about cursor positions. So let's get into that. We're going to now talk about displaying integers on the graph screen, which is the screen that we were drawing shapes on and putting text on. So remember, to set that up, we're going to need to use det0, and we're going to want to pause before it exits. And then after that pause, we need to shut down our graph screen. So we're going to use det1. Okay. If we want to fill the screen with a color, we have to use det5, and we'll just color it white, even though it is white by default, just to make sure it's going to be clear. Okay, so say I have my random value, and we're going to just take a random value that's going to be between 1 and 20, and we're going to store that in our, let's just call a variable rand for random. In fact, we can just call it random because we can have up to 10 characters. So we're going to store that in random, and now we want to output that variable. Well, we can use det16 to output it. So we need det16, and then we have to type the name of our variable, which you remember is random. And now we have another argument, which is the number of characters. So we need to tell the program how many characters of random to output. It's important that we don't tell it too few. If we tell it to output 1 character, but our random number is 15, say, 15 has 2 characters in it, a 1 and a 5. So this is going to get messed up. If we put 2 and the number is, say, 5, it's going to output 0, 5, which is okay, but it might not be what we want. So we'll talk about, when we talk about call, I'll show off a method that would help us with this problem. For right now, this is how we're just gonna do it like this. Now here's my problem though. Where is this actually going to output? It just says random, 2. There's no instructions on where to put the random number. Well, that's because it's going to output this at the cursor position. So if I have, we talked about writing text to the screen, and we used det18 and then our text. So let's write out some text. So we have text here, and then this command takes an x and a y value. So let's put it at 10, 10. Now, this text position, this is going to be where the text starts. And as it writes the text, it's going to increment the x coordinate until it writes this last character. So now the cursor, after it writes a string, the cursor position is now going to be at the end of that string, which means if we output our random number now, our random number is going to use the end of this output as the position where it will go on the screen. So let's try that out. If we run ICE, we compile our program. Okay. So look at that. It wrote number out, and then immediately after it follows our random number. And our number is 15. We didn't tell it to be 15. We told it to be a random number, and it chose 15. If we run it again, we get 8. So look at this. The 8 is 1 character, but because we put 2 characters, it outputs it as 0, 8, which might not be something we want. So how do we get around that? Well, let's say I wanted to, let's create another variable to fix this problem. So let's call this number of characters to output. So we'll just call it cars, characters to output. And let's do an if statement. So let's say if our random is greater than 9, right? That means that it's going to be double digit. So we can store 2 in the amount of characters to output. But if it's not greater than 9, that means it's single digit, which means that we can just output one character of it. I'm just hitting menus by accident there. That's nothing that you have to do as well. So now it should pick how many characters are the correct amount to output. Okay, so this is all good, but what if we want to put our number anywhere on the screen that we want to? We don't want to have to follow text. So how do we set the cursor position without actually writing out text? Well, there's a command for that, and it's a det command, but off the top of my head, I don't quite remember what it is. So I don't know if I've talked about this before, but if you hit trace on your calculator after running ICE, you can see all the ICE commands. So I simply have to look for what I'm looking for. So I'm looking for like a set text position, probably, right? Something like that. And I can see set text XY. Well, that looks like what I'm looking for. So I select that, and it's det 19. So now I know. And now I don't have to remember all these det numbers, because I can just use my menu to pick out the command I want. So now that I know how to set the X and Y position of my text, let's set the position of our text to 50, 100. And let's see what happens. So we'll run ICE, and now our text appeared at 50, 100, which is where we wanted to put it, and we were able to choose that without having to write other text. And you can see the number was 20, and it outputted 2 characters. So let's keep running this and see if, oh, there we go. First try, we got a single digit number. And look, there's no 0 in front of it like there was before. That's because we had that if statement that said that if it's a single digit, only output 1 digit. So now we don't have to have that annoying 0 in front of it. So that's about all I have for today. In the future, we will talk about other types of variables and more uses for the variables that we have now. For right now, that's all I have. Thanks for watching.